Hello everyone, so today we are here to solve this LeetCode problem number 2187. It's minimum time to complete trips. Let's read the description. You are given an array time where time I denotes the time taken by the ith bus to complete one trip. Okay, each bus can make multiple trips successively, that is, the next trip can start immediately after completing the current trip. Also, each bus operates independently. Okay, that is, the trips of one bus do not influence the trips of any other bus. You are also given an integer total trips, which denotes the number of trips all buses should make in total. Okay, return the minimum time required for all buses to complete at least total trips. Okay, let's look at the example. So we have been given time, and this is the time that each bus take to complete one trip. So bus 0 takes time 1, bus 1 takes time 2 to complete one trip. This bus takes time 3 to 3 time to complete one trip, and we have to complete total 5 trips. Let's look at the exam explanation. At time t equals to 1, the number of trips completed by each bus are 100 because it's completed in 1. These are not completed because these will be completed in 2 and 3 seconds respectively. Then total number of trips completed is this. At time 2 this will also be completed, and this will complete 2 trips, so this will be 210. And same at time 3, this will have been completed 3 times, and this will be 1 time. This will also be 1 time, so that is 5. 3 plus 1 plus 1, so we have to return this. Okay, so let's try to understand it. So time is 1 2 3, total trips equals to 5, and then we have to find that. Okay, what we can do is we can, just like we did in the explanation, did t calculated for t equals to 1, t equals to 2, t equals to 3. We can start for t equals to 1 2, and and keep going until we complete at least these least trips equal to total trips. Okay, so that's one way of doing it. So that will be like for each time iterating over this and then checking if the total number of trips completed is greater than equal to this or not. And yeah, so let's look at the constraints and if we can implement our solution. I think the constraints are a bit too tight for this solution. It's going to be like O of k multiplied by m, that is input and time. So that's one thing. Okay, if you notice here, then there will be cases like it will go something like t equals to 1 cannot complete, t equals to 2 cannot complete, t equals to 3 cannot, t equals to 4 can complete, and now onwards it can complete. For 5 can complete, for 6 can complete, for 7 can complete. So I think we can improve this. Instead of doing it linearly, what we can do is we can uh, run a binary search kind of thing, and if it has completed, if it has completed or not, and then we can run our algorithm on this and then try to find the first uh, can complete use case. So for this, the outer range, left left side will be equal to, at least we will require at least one unit of time to complete the trip, since total trip is at least equal to 1. And then for right, right will be, we will have to keep the right big enough to accommodate uh, everything, like make sure that it can complete this use case. So we can keep right as right equals to, so we need this many trips, so we can do it total trips and how much one trip takes time, so that will be uh, equal to so if this takes one time, then at most 5 unit of time will be needed for this. So we can do min of time, so this min will be enough 5 number of times to get this. So this will be like this. Okay, let's try to implement it. Let left equals to 1, let right equals to total trips multiplied by math dot min of time. Okay, and then while left is less than or equal to right, we keep doing this. Let mid equals to, mid will be left plus right whole divided by 2, and we will have to parse it. Or like for this we can do math.floor, right? Now what we have to do is, like in the binary searches we do, if we have to see if we can complete the, the total trips in required number of like if we can complete these trips in this time. So this will be another function. Let's declare it here, where can complete equals to let's instead of putting it here, let's move it here so that we don't have to pass many many things. We can simply pass t, and here we will do can complete t, and if we can complete we will do if we can complete, then we will move to left. Since suppose we can complete here, then we will start checking from here. So this will be right equals to mid minus 1, otherwise else we will do left equals to mid plus 1, and in the end we will simply return what we will return? We will return left. Let's move our function here and then solve it. Let trips completed equals to 0, and then we can simply iterate over this. Let time trip time of time, and we can do trips completed plus equals to t divided by trip time. Okay, and we will have to like do math.floor because you don't want float numbers, and then in the end we can return if this is greater than equal to total trips, then we return true, otherwise we return false. I think that's all. Let's try to run it. J failed, T is not defined. Yeah, right, it's gonna be mid. And it worked. Let's try to submit. It worked. Thanks, that's all for today. And if we talk about the time complexity, it's the same as for the time complexity of binary search. So it's going to be O of n log n, but since the other factor, this left and right, is not limited to this time, so it's going to be something like O of n log k. So yeah, that's all. Thank you. Bye bye.